Hello students, this is our tutorial form, and today I discuss a very special topic, very important for competitive exams and for master degree level exams for bachelor degree of examination. So, and it is a core point for linear transformation, which is I call matrix representation of linear transformation. Very important topic. So let's start. So first, I appeal all of you to subscribe this channel. If you have not subscribed, subscribe this channel. You will get all these videos. So let's start. We'll first consider a linear transformation T from U to V, where U has dimension uh, m and V and dimension n. All are there are two. These are two vector spaces over the field. It can be real or complex. Both are vector spaces. So, the linear transformation from a vector space U of dimension m over the field A, it can be real or complex. And to this transformation from UM to Bn. Bn is also a vector space of n dimensional. It is also over field F, which is real or complex. So now we take ordered basis. Basis, you know about this. What is base? You know. If you don't know what is ordered base, then find out my channel, my videos. You will get there. I will reload what is basis, and easily you if you know what is base, then you can easily understand what is ordered basis. So I am taking ordered basis for UM. UM. This is alpha 1, alpha 2, alpha n. And the ordered basis for BM is beta 1, beta 2, dot, beta n. So these are the ordered bases. Now we'll have to deduce the linear a matrix which is relative to the transformation. So how we can obtain? So we have to follow. You have to remember this first, that the order basis for the UM is alpha 1, alpha 2, alpha m, and Vn for Vn is beta 1, beta 2, beta n. So now I am creating the matrix in this way. First step, E, alpha 1 will be E11, beta 1 plus E2 plus beta 2 plus E23 A N1 En1 beta beta n. These will be actually, I am writing in this way. It means that T alpha 1 will be the column vector for the matrix. That's why I am writing in this way. So T alpha 2 in this way, what will be? T alpha 2 will be A. It's very important to represent matrix representation to understand. Very, very important. 2 1 beta 1 plus A 2 2 beta 2 plus A. This is 1 2, this is 2 2, then will be 2 3, then will be 2 4, and next last will be 2n 2n beta n. And in this way it will take the last order basis transformation T alpha n, then it will be T alpha m, sorry, m, then it will be A 1m. All these are column vectors for the matrix we wish to obtain. So all the column vectors. That's why I am writing in this way. Beta 1 A 2A. The order I am writing is very important. You have to remember in this way and not another way. So you have to watch carefully. Plus the last element will be A N Mn. Then wrong. This will be right. This will be actually AN2, A12, A22, A23, A24, A22, A32, A42, height, then 52, then 62, then last element will be N2, N2 beta. This will be A N N M. You are looking that way, it is very hard to arrange this and to represent to find out the parameters of the uh, matrix related with the linear transformation. So very important and very carefully you have to watch. Then we can generate the matrix for this linear transformation. So we have the we are writing the matrix A. Actually, this matrix it is related with, can be represented also in this way, uh, matrix P related with the basis B of the uh, domain vector space and the range vector space B slash. So in this way, this matrix related with the transformation is represented. So this vector can be now write down. I have said that there will be first T alpha 1 is the column vector. So here will be A11, A21, and at last A N1. So then there will be T alpha 2 as a vector, column vector. So there will be A 1 2, A 2 2, and at last A n 2. And if we continue this, then last will be A 1, A 1m, A 2m, and the last element will be A n. So this is our desire to find out the matrix related with the transformation. Very important. We further study some important properties of this matrix representation. Very important, which is very important for computer science actually, that this should be invertible for if you find out that T is invertible. Invertible means that T is 1 1 on 2 or bijective. So for T would be 1 1 on 2 or bijective, T should be 1 1 on 2 or bijective. A needs to be invertible, means non-singular. Determinant A cannot be equal to 0, not equal to 0. Then we say that T is invertible. So for checking that interlinear transformation is invertible or not, we need to find out the relative matrix with the transformation and find out that it is singular or non-singular. Non-singular means all these uh, range vectors, column vectors must be linearly independent. Then it is non-singular. So further we can study that one more property, that this any matrix representation related with transformation must be unique. You cannot get many matrix, just unique one. A unique matrix you can find out, not more than unique. Also, I used to know. I want to tell that all the alpha 1, alpha 2, alpha n are the coordinate matrix of alpha with respect to b, basis b. Alpha 1, alpha 2, alpha 3. I am writing here all the matrix alpha I from 1 to n I is equal to 1 to n. So all these alphas are is a coordinate matrix with respect to the ordered basis. With respect to the ordered matrix basis, coordinate matrix with respect to the coordinate matrix and with respect to the ordered basis b, beta, sorry, b, sorry, not b, beta b. Ordered basis b. This was taken alpha 1, alpha 2, and so alpha 1, alpha 2, alpha 3. So this ordered basis is the coordinate matrix, and the T alphas are coordinate matrix This is a coordinate matrix of alpha actually. With respect to order basis B. P alpha is the coordinate matrix with this of T alpha matrix of T alpha I T alpha with respect to the order basis B slash. These are the important information property you have to remember. One important, very important information I must want to provide you that if there are two transformation, one is from UM, a vector space UM to vector space VM, and one another linear transformation is from UM to VM. There are two linear transformation, and we are taking the order basis for this B, and for this order basis is B slash. So this is also this for this also there will be B, and for this will be B slash. Then if we add this two linear transformation, what will be the if we take at a time t plus add this two linear transformation and find out the relative matrix with respect to B and B slash, then the relative matrix will be equal to the linear transformation, very important linear transformation E with respect to B and B slash, and if we take this matrix relative with T and take another matrix with relative with S with respect to B and B slash, then and add up these two relative matrix, then we will get the T plus S. One means add of the two linear transformations relative matrix. Very important, very important property, and also it satisfies that it will take any constant one multiplying with constant with any linear transformation Ct with the relative matrix B order basis with respect to the order basis B and B place, then we'll get C times of the linear transformation T with respect to the order basis B and B prime. You can understand this that if you wish to know the C types of any linear transformation, then you will have to find out the this that with respect to the ordered basis, the relative matrix. If you multiply with the constant C, then you will get the C types of the linear transformation. So these two properties is very important. So I hope you like this video. There are many properties related with the uh, relative matrix in matrix representation, but I just discussed some important ones. And if you further need anything to know, inform me. And if you like, then like. And thanks for watching. If you have not subscribed this channel, to subscribe this channel. Thanks for watching. Have a good day.